So this problem is similar to homework 2 problem 10, just a few numbers changed. The problem gives us a gun aimed horizontally. Oh, this is the wrong clickbait. Wrong copy pasta. God damn it. Piece of shit. Like it sucks. So this problem is similar to homework 2 problem 11. A few numbers have changed. This problem tells us that a supply plane, draw a plane, P, it is 150 meters above a glacier, and it moves at 50 meters per second. And they're trying to drop at like a camp, drop a little tent. So at what distance, delta x, should they drop the package? Right? How do we know how soon they should drop the package? Well, we're given a v initial, we're given the height it falls, and we're asked to find the change of position in the x direction, be some known number. Well, this is two-dimensional kinematics, and we know our first step is usually just the position equation. So let's write that up here. Where x is x initial position plus initial velocity plus 1/2 at squared. And so in the x-axis we have, well, we're going to pick our origin as the plane. So we're not going to have any initial positions. Our initial x velocity is 50 times time, and there's no acceleration in the x direction. Our y-axis, once again, initial positions are all 0, no initial velocity in the y direction, and then we have a negative 9.8 over 2 times t squared. And our acceleration is just gravity, because we are in free fall when we drop that supply crate. So how do we solve this? Well, the only other information we have is 150. It's the only number we haven't used yet, and that's a y distance. So what if we plug in 150, and let's make sure that's negative, right? Because we are dropping the package downwards, and that's going to be the negative direction. And you'll see we can actually solve for t by doing so. And so doing a little bit of algebra, we find that t equals the square root of 2 times 150 divided by 9.8. And that comes out to be 5.5 seconds. Well, now we have a time, so we can go back to our x equation and use 50 times 5.5, and we can figure out that change in x position, right? 50 times 5.5 gives us 275. And that's going to be in meters because we're working with position. And that is the change in position of the supply crate from when they drop it. So they have to drop the supply crate 275 meters short of the camp if it wants to hit the camp dead on.